This is R.D. Sharma Solution Class 12, Chapter 6, Determinants. VSAQ, very short answer questions we are taking. A matrix A of order 3 by 3 has a determinant 5. What is the value of 3A, thrice of A, then the determinant of that value? Now, this is a very straightforward question with a simple explanation. The explanation is that if you have this 3, let us call it as k, some k. Now when we try to find out the determinant of this k when you take it outside, you are taking it outside from either 3 rows or 3 columns. So it is k to the power n. N is the number of rows and column. Okay? K is a constant. N is the order. So it is k to the power n. So here we have 3 as k. Order is also 3, so 3 by 3, 3 raised to the power 3, and the determinant of A. And since the determinant is already given as 5, so you just have to multiply this 5 with the 3 to the power 3. Okay, if the order would have been 4 by 4, it would have been 3 raised to the power 4. Order 5 by 5, it is 3 by 5 in this case. So how do we do this? First, we will take the order. This is k, we are taking k outside, raising it to the order, power of order, 3 to the power 3, and the determinant. Determinant has the value 5. So 3 raised 3 is 3 into 3 into 3. 3 is 9, 9 3s are 27. So 27 into 5. This is going to be 135 because it is 27 into 5 and that is 135. Or expanding by first row, the value of the determinant of 3 by 3 square matrix. This A is given as Aij. This is A11, C11, A12, C12, A13, C13. Now A11, A12, A13 can be either a column or a row. But the second part, that is C, is the cofactor. If it is A11, it will be C11. A12, it will be C12. That is the cofactor corresponding to that certain value. Write the expression for its value on expanding by second column. This question is saying about first row, asking about the second column. So there are 3 rows, 3 columns which I am making now. So A11, A12, A13. This is how the values are represented. Aij, I is for row number and j is for the column number. So A21, A22, A23. A31, A32, A33. 3 rows, 3 columns. Okay. Now, when we want to expand it using the second column, where is the second column? Let me just change the color. This is what we are calling as the second column. A12, A22, and A32. And what are the values we are going to put here? The cofactor and the subscript will remain same. A12, C12, A22, C22, A32, C32. This is your answer. Now, this is how you are going to do it. These are the whole steps which you have to follow. But I have given you the logic, what it actually means. So, let me just clear it and you can have a look here. Let Aij be a square matrix of order 3 by 3 and Cij denote cofactor of Aij in A. If determinant of A is equal to 5, write the value of A31 C31 plus A32 C32 plus A33 C33. Okay. Now the simple explanation is, whichever way you take the determinant is going to be the same value. Any row you take to open the determinant, any column you take to open the determinant, the value of the determinant will not change. Since the determinant is already given as 5, you take any ways, either ways, the determinant will remain same, is going to be 5 always, right? So now this is A13, A1, the question is asking about A13, C13, A23, C23, A33, C33. So basically you are opening it using the third row, but determinant won't change. In question 18, write the value of A11, C21, A12, C22, A13, C23. Remember, we talked about A11, C11, A12, C12, A13, C13. But here, the cofactor is not corresponding to the value. So we already know that if we are talking about a square matrix of say order n, the sum of the products of element of a row or a column with the cofactors of the corresponding elements of some other row or column is 0. That is, we are taking the value, but we are not taking the cofactor of that value. We are taking the cofactor of some other row or a column. Then the value will be 0. You remember, we just talked about A11, the C should be C11. The cofactor has to be the same. Cofactor should be corresponding to that particular value, but it is not in the case. Since the elements of the first row here in this example and are of the first row, A11, A12, A13 are the elements of the first row, and the cofactors are the elements of actually the second row, which is C21, C22 and C23. And we know already with the properties when we discussed that if we multiply this kind of way, then the corresponding value of the determinant is going to be 0. I hope you got the idea. If I take A11 into C12, A21 into C22, A31 into C32, it's also going to come as 0. So either ways you take any column value with corresponding some other column or say row cofactor is going to be 0. This is a rule. You need to know it. Write the value of this. So you just have to do it. Means just cross multiply and subtract. Sin 20 multiplied by cos 70 minus cos 20 sin 70. Since it is negative becomes plus. So sin A cos B plus cos A sin B, that will be the answer. But here we have a trigonometric identity. This is sin A cos B. If I take 20 as A and 70 as B, sin A cos B plus cos A sin B will be sin A plus B. So sin 20 plus 70 is sin 90, and sin 90 is what? Is equal to 1. If A is a square matrix satisfying A transpose A equals identity matrix, write the value of this determinant of A. Please remember, if a matrix, the determinant you find out, and you take the transpose of that matrix and take the determinant, they won't change. They won't change. So I'll show you step by step how we are going to get this value. A is a matrix. It is square matrix. The order is n by n. When we take the determinant of matrix, if you take the determinant of A or determinant of A transpose is simply changing row to column, and it is going to be same. It won't change. First thing, okay. Now A transpose A is given as identity matrix. Let us take the determinant both sides. When we are taking the determinant of what? The identity matrix. For example, 2 by 2 identity matrix. So I told you that when we have identity or scalar matrix or diagonal matrix, just multiply the diagonal values. That will be the determinant of that matrix. So it will be 1. Determinant of I is 1. Now since A transpose is 3 by 3, A is also 3 by 3. Okay. Determinants are of the same order, and we know that A into B or determinant can be written as A and B separately determinant and multiply. That is A B determinant will be A determinant B determinant. So how are we going to write? A transpose and A equals 1. Okay, that is the determinant of A is 1 over A raised T. But we know that transpose and the actual determinant, the determinant remains same as I just said. So you can write it as again A transpose is A. Now you just multiply across. The determinant of A square is equals 1. Determinant of A will be plus minus under root 1. Under root 1 is 1, so plus minus 1 it will be. Right? Plus minus 1. If A and B are square matrices of the same order such that the determinant of A is 3 and AB equals I, then write the value of determinant B. Okay, so we'll apply the same property since if the square matrices are of the same order, then there is a property of determinant, that is AB multiply, then take the determinant will be A determinant separately with B determinant. And since determinant of A is already given as 3, and this A and B, if you multiply, it is I. So just write I here. And we have already seen just now that the determinant of identity is 1. So it is 1 equals 3 B and B 1. You can take 3 on the left hand side. It is 1 by 3. A is a skew matrix. A metric of order 3. Write the value of determinant A. And there is a concept, there is a property. We just have to understand this one, that skew symmetric is when you take the transpose of any matrix, it should come as negative of that matrix. A transpose minus A. So if the order is even, that is the n by n order, n is even or order is odd. If order is even, there will be some value. But if the order is odd, the determinant will be 0. Right? Now what is the order of this particular, in this particular case? The order is 3. Is it even or odd? It is odd. So when it is odd, that means the determinant of skew symmetric will be 0. Determinant A is 0 because the skew matrix, it is skew symmetric, and of course the 3 is odd. If A is a square matrix of order 3 with determinant 4, then write the value of minus is there outside. You can take a minus outside. How? We just saw in this previous question that if we have a determinant with a scalar multiplied inside, minus means what? You can write it as minus 1 into A, same thing, inside the determinant. Now this minus, assume it to be K. So when you take Ka, when you try to find out determinant, it will be K raise n when it comes outside of the determinant, and then determinant of A remain inside. So K raise n, K is minus 1 to the power n, and inside you have determinant of A. So minus 1 to the power 3, determinant is 4. So it is minus 1 into minus 1 into minus 1. It is going to be minus 1 only, and minus 4 it will be. If A is a square matrix such that determinant of A is equal to 2, write the value of A into A transpose. A into A transpose. So in a square matrix, A transpose, the value won't change, determinant won't change. So A dot A transpose, because the orders are same, so you can just write it as A determinant and A transpose determinant. I told you AB determinant will be equal to A determinant multiplied by B determinant. The value of determinant of A is already given in the question. It's 2. So if you take the transpose or whichever, I told you the determinant won't change. So determinant of A and determinant of A transpose will be same. So it is 2. 2 into 2 is 4. The answer is 4. Find the value of the determinant. Now you can do it directly, but it will take time and answer will come same. That is why we need to learn the properties of the determinant. We'll apply the property here. The property is to make this determinant easier. And most of the time when we apply the property, most of the time the determinant comes to be 0. Because these are very small answer question. Then rather than doing all, try something so that the determinant computation becomes easy and it may come as 0. So this is row 1. We have row 2 and row 3. Now you see 81 into 3 is 243. 52 into 3 is 156. 100 into 300 is 100 into 3 is 300. So if you multiply the second row with 3 and subtract the first row and second row, you are going to get 0. 100 multiplied by 3 is what? 300. So let us multiply the second row with 3 and subtract it with the first row, and that is going to come as 0. Hope you got the idea. We subtract them. So R1 we are changing R1 minus 3 into R2 because 243 is 81 into 3. 156 is 50 into 3. 300 is 100 into 3. You can take 3 outside anyways. So 2 rows become same. So the logic is same. You can do it using the row properties, or you can just subtract these two, or you can say 2 rows are same. The determinant is 0. 2 columns are same. Determinant is 0. So this 0, 0, 0. This says the whole row is a 0 and the determinant is going to be 0. Write the value of the determinant. Okay. Now you see, as I said, there are multiple ways to do it. 2, 4, 6. 2 is 2 into 1, 4 is 2 into 2, 6 is 2 into 3. So I am just taking 2 outside. What it will be? 1, 2, 3 inside. Minus 3, minus 6, minus 9. Minus 3, can I take minus 3 outside? Yes, minus 3 I can take outside. What will be remaining? Minus 3, minus 6 will be 2 and minus 9 will be 3. 5, 10, 15. Can I take 5 outside? Yes, 1, 2, 3 will remain. So the 2 rows and 2 columns, if they are same, means 2 rows or 2 columns are same, the determinant will be 0. Here you see all the 3 columns are equal, that means 0, right? Now there are, as we saw in the previous question, we can apply the property also. What is the property? You can do R2 minus 2R1. R2 because 4 is 2 into 2. That is how you can do it. If the matrix this is singular, find the value of x. Singular is cross multiply 5x multiplied by 1 minus 2 multiplied by minus 10. So it will be plus 20. 5x plus 20 equals 0. X will be equal to minus 20 by 5. So minus 4 it will be. X is minus 4. Right? If A is a square matrix of order n by n such that determinant of A is equal to lambda, then write the value of minus A determinant actually. Now we just saw a question and what it will be? Minus A means minus 1, it is minus 1 into A. When we take it outside, it will be to the power of n. That is the order. Determinant will remain inside. Determinant of A is lambda minus 1 to the power n lambda. This is the answer. Find the value of the determinant. Now either you open it and solve it. That will take a lot of time. Let us apply the property. The property is just take the scalar outside. Let us take certain thing common factors. So from you can take it from rows or column, either way, it's up to you. So we are taking 2 square from the first row. It will be 1 here, 2 here and 2 square here. You can take from second row, you can take 2 cube common. It will be 1, here 2 square. Let us take 2 to the power 4 common from third row. 1 to 2 square will be there. Now you see all the 3 rows are same. When the 3 rows are same, that means it is 0. Or you can say 2 I can take from second column and 2 square from third column. All will be 1, 1, 1, 1, 1, 1. It will be 0. Okay, this question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.